Hello, students. Hello, how are you? It's Amir once again, and this is our lecture number 8, and it is related to movement, right? So let's start with that. Let's proceed. In the previous lesson, we have finished few topics. In this, we will try to finish up the movement and some problems related to that. Now, question is, what is meant by movement? Remember that there is another name for that, and we called it talk as well. What is movement? Movement is what? Now, the basic definition for movement is it's a turning effect of a body, effect of a body about a fixed point. Sometimes we do call that fixed point as a pivot. Now, what exactly that means? Let me give you an example for that. Let's suppose if you fix that side of an iron rod or something here, for example, if you fix it, what will happen? It cannot be moved from it. If you apply a force in the downward direction, or let's suppose if you apply a force in upward direction, that rod, if you apply it to if apply a force in the downward direction, it will try to rotate this particular rod in clockwise direction about this point, like that, right? And if you apply a force in an upward direction, it will try to rotate that iron rod in anti-clockwise direction about that fixed point. Now, this fixed point is called as pivot, right? So basically, that is what we called as turning effect, because that particular force which you are applying here tried to rotate this object about this fixed point, right? So, what is important in case of movement? There are two, three things which are very, very important. One thing is called as this pivot, which is a fixed point. Then one thing is also very, very important is definitely the magnitude of the applied force. More force, more turning effect. Now, mathematically, what is it equal to? That's what the point is. So, mathematically, moment is equal to force multiplied by perpendicular distance. Distance between force and fixed point. Now, this is very important. It should be a perpendicular distance. Now, I'm giving you an example, then you will understand. Let's suppose this is a door, right? And this is fixed from this point, hinge, or you can say pivot. Most of the time, you will always see that the handle of the door is always here. The question is why this is always here. Why not this handle is here, 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 here? The reason is very simple. As a movement is directly proportional to the distance between the force and the fixed point. So it means that distance should be as maximum as possible. So if distance between force and application of force, I mean, between the force and fixed point, which is called a pivot, is maximum, moment will be maximum. That's why we always put the handle at a maximum distance from the fixed point. You never put the handle here. That's the first point. So if the distance between force and pivot is maximum, the moment will be maximum. Second thing is, why not you put the handle here, 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 here? because you need a perpendicular distance, and that distance will always be the perpendicular distance between the fixed point and the point of application of force, right? So two things are very, very important. One thing is the distance should be perpendicular. And second important part is that should be at a maximum distance from a fixed point. So it should be at a maximum distance from fixed point. Now, few more things what it shouldn't be. If you apply a force on a hinge or a pivot point, remember that force applied on fixed point produce no moment. So moment will not be produced if a force is applied on a pivot. Remember that. Second thing, if you apply a force in this direction or in this direction, rather you are applying force outward or inward, you are applying the force from left to right or from right to left, which is in that way, the line of action is passing through the pivot, it will not contribute. It will also not contributing. So if a force is passing, I mean, its line of action is passing through the pivot, again, it will not be contributing. That's what the point is. So two kind of forces will not contribute in any moment. One force, if the force is applied on a pivot, and secondly, if the force is applied in such a way that its point of action is passing through the pivot. Right. One more thing which I wanted to tell you here, then we will go with this numerical, that force and distance are inversely proportional. If distance is maximum, even the less force can be applied to bring you a certain amount of a moment. If distance is less, you need to apply extra amount of force to actually fulfilling the moment requirement. So both force and displacement are inversely proportional. Now let's come to the numerical here, and so that you will understand what is a concept behind the moment. A carpenter attempts to loose a bolt that has rusted. To turn the bullet, they exert a force of 22 Newton. So force is given 22 Newton using a spanner of length 20 centimeter. Distance is given 20 centimeter, which means 0.2 meters. The force is exerted 5 centimeter from the end of the spanner. So distance of the application of the force, it is 5 cm, which is 0.05 meters. Calculate the turning effect. Now, it will be like this. For example, this is the bolt, this is the spanner, and force is applied 5 centimeter from the end of the spanner. So basically, this is the spanner. This is 5 centimeter from the spanner point of view. So technically speaking, if a spanner is 20 centimeter long, a spinner force is exerted 5 centimeter from the end of the spanner. So what exactly is a theory behind it? How to do this? Now, it means that force is not applied here, but the end of the spanner means here. So basically, it's say this point. So rest of the 5 centimeters is not being used. So technically speaking, D value, it's not the D value. D value should be 0.2 minus 0.05, right? So what exactly it is? Let me just quickly calculate it. 0.2 minus 0.2 minus 0.05, it gives you 0.15 meters. Now, what is the moment? M is equal to force is 22 multiplied by 0.15. So it will be how much? 22 multiplied by 0.15. So the moment is equal to 3.3. Now, the unit we didn't discuss. Force into perpendicular distance, right? Force unit is newtons, distance unit is meters. So the unit will be Newton meter. So this is the unit of moment. Now remember that movement is a vector quantity, so it should have a direction, either clockwise, either anti-clockwise. So movement has a direction because it has all that. So this is the small topic related movement, which we have just discussed. And this is the end of lecture number 8. In the next lecture, we will start a topic named momentum. So in lecture number 9, we will discuss what momentum is, and then there are subtopics relevant to that we will discuss in that lecture. So I hope you understand that. Hope to see you in the next lecture, which will be lecture number 9. So it's bye from my side. Take care.